Hello, I'm Rebecca the Maths Lady and welcome to this video which is all about algebraic notation. In this video I'm going to teach you how we introduce children to algebraic notation. I'm going to talk about commutativity and the algebraic notation associated with that, and I'm also going to explain how we teach the topic of order of operations, which is also known as BODMAS or BIDMAS. And it's in this video because I also link that topic to algebraic notation. As we work on this topic, I'm going to try and explain how valuable this topic is in consolidating all the number work that children have done in primary maths. So if you don't need this video, here's your skip link to your next one, which is all about missing number problems using algebra. This video assumes children have a basic understanding of the four operations and a little bit about square numbers, but there's nothing particularly challenging, so there's no videos you really need to watch before this one. But if you come across a gap in students' knowledge, then please do look at the list of videos that are available at authenticmaths.co.uk/videos, and you'll be able to find a video on the topic you're looking for. Okay, let's get started with teaching algebraic notation. And I'm talking about children being able to evaluate these kinds of expressions. Now, most maths is logical, and our key emphasis in teaching is on making sure children deeply understand and can visualize the structures of number and the structures of what's going on. But some maths isn't. And when we introduce mathematical vocabulary, that's not logical generally. You just have to learn words and definitions. Similarly, algebraic notation is often not logical, it just needs to be learned. For example, in here 2a, well, that could be 20a, it could be 2 add a, it could be 2 subtract a. It's quite arbitrary that it happens to be 2 lots of a. That's something that needs to be rote learned through clear explanation and loads of practice until children just know it. And I don't say that about much maths, but I am saying it now. So the key art of teaching children to use and understand algebraic notation is just to give them loads of practice. I've developed this worksheet and it'll be free shared in all the usual places, and you can change the letters, you can change the expressions if you like, and it is important to change the letters from time to time so children don't think this is just about A and B. But it's set up so you can use this worksheet many times, and you could just display it and get children to write the answers if you wanted. The way I would use this with a class is I would give two simple numbers for A and B, integers up to 12. So let's say A equals 6 and B equals 3. And I would also give two hard numbers. Now they could be fractions or larger numbers. Let's say A equals 12 and B equals 260. And in order to do this topic, we want all children to be able to work through these. And of course, we wouldn't introduce them all at once, we'd introduce them gradually, so they built up their familiarity with different algebraic expressions over time. We can incorporate larger numbers, decimals, fractions, possibly even a challenge of negative numbers as an extension activity, and children don't have to get all of these. They need to get all of these, but anything they get from here is a bonus, and it's absolutely fine to come across something like division of fractions and say, oh, we don't do that at primary. They can have a think about it, they might come up with some ideas, but it's actually really healthy for children to come across maths they can't do yet. Right, let's go through these and see how they work. So I've said A equals 6 and B equals 3. So A add 3 is going to be 9. That's just 3 more than A. B subtract 4, and we're really thinking about the essence of subtraction here. That's 4 less than B. 4 less than B, all children should be able to know that is -1. And if they don't know it's -1, you can get your number line or your counting stick out, start at 3 and move back 4. 10 subtract A, 10 subtract 6, that's going to be 4. A add B, that's 9. 2A, and here's your first tricky bit. It really needs to be learned that 2A means 2 times A or 2 lots of A. So that's going to be 12. 5B similarly is going to be 5 lots of 3, which is 15. A over 2. A over 2, that's A halves, 6 halves. 6 halves is 3 wholes. And it's also useful to learn that this way of writing something just means division. If you write one number over another, you're just dividing them. So if we go to this one, A over B, that's 6 over 3, 6/3, which is 2 wholes. Now, sometimes that won't drop out as a whole number, and it's fine just to leave it. If you want to lean into the fact that a division is a fraction, here's a link to a video that explains that in more detail now. You may find some books that write A divided by B or A divided by 2, and it's okay to stay with that for a while, but they will be moving on to this very soon at secondary school. So if you can move towards this notation, it's much better in the long term. AB, when we put numbers and letters together without any symbol as to what to do, it means multiply. Need to learn that. So that's 6 times 3, which is 18. 3AB means 3 times A times B. So that's 18 times 3, which is 54. 2 A's subtract 5. That's double 6, which is 12. Subtract 5 is going to give you 7. 2 A's add 3 B's. 2 6's are 12. 3 3's are 9. 12 add 9 is 21. And then we get on to our brackets. 2 lots of A add 3. And the children need to know that they need to do the inside of the brackets first. A add 3, A was 6, so A add 3 is 9, and we're doing 2 lots of that, so that is 18. Pretty tricky, needs lots of practice. 3 lots of A add 2B. Well, A add 2B is going to be 12, so 3 lots of that is going to be 36. A lots of B subtract 1. Well, B subtract 1 is 2, and we want 6 lots of that, so that's going to be 12. Now, what about this one? That's a really important bit of notation to practice, and it's a great time to practice square numbers because that means A squared. And A was 6, and 6 squared. You can build the square, remember. Here's a link to the video on square numbers if you need to recap it. 6 squared is 36. And then children can have a good go at this column here and do what they can. It's going to keep them busy. It's going to be a good challenge and stretch while you can make sure that every child understands these. After a certain point in time, I would get children to work in pairs to check each other's answers so that they're discussing their strategies and they're thinking with each other and correcting mistakes. But of course, as a teacher, I'd also have an eye on what everyone's doing. And I'd have my own completed worksheet just to wander around and do a quick check. So as we work on this exercise and exercises like them, as I said, we can vary the difficult numbers, and it gives us such a good opportunity to practice all our primary number work. A might be a third, B might be 2/5. Lots of challenge in that, and that could lead on to a whole lesson which is a consolidation of our work on fractions and an acknowledgement at some stage that children don't know how to divide fractions by fractions. But they can actually do all of the rest of those by now. And when they come across calculations that you haven't taught them how to do, it's a wonderful stretch and challenge for them to think. If you've taught everything with structure in the way described in these videos, your students will be able to have a good go at questions you've not taught them to be able to do. If your students have just been taught recipes and spells and procedures to follow in specific circumstances, they're not going to be able to do them at all. Okay, the next challenge is to explore commutativity using algebra. So the first two questions I would set children would be these two. A add B equals B add A subtract B equals B subtract A. And I would ask them in their groups to explore whether these statements are always true, never true, or sometimes true. And if they're sometimes true, when are they true? And when they've been exploring that for a while, you can listen to their answers and generate hopefully a really powerful discussion. And it turns out that this statement is always true, whatever the numbers. So 3 add 5 equals 5 add 3, because when you're adding, you're just putting quantities together and it doesn't matter what order you put them together in. But this statement generally isn't true. 5 subtract 2 does not equal 2 subtract 5. And some students may think it does, so it's worth playing around with that. It's worth thinking about money, maybe. £5 and you spend £2, you've got £3 left. If you've got £2 and you spend £5, you're in trouble. It's not the same situation. And it turns out that that statement is only true when the two numbers are the same, because both sides are going to be equal to 0. So addition is commutative, the order doesn't matter. Subtraction is not commutative, the order does matter. And then we can look at multiplication and division in the same way, perhaps in the next lesson. Is it always, sometimes, or never true that AB equals BA? And is it always, sometimes, or never true that A divided by B equals B divided by A? Well, that turns out to always be true because of array. It's the, well, I looked at it this way rule of multiplication. A rows of B are always going to give the same number of squares as B rows of A, because it's the same rectangle just turned round. And here's a link to a video that explains more about that if that's just confused you a little. So multiplication is commutative, but we can easily prove division isn't commutative just with a counter example. For example, 3/7 and 7/3. They are clearly not equal. So division isn't commutative. And again, it turns out that that is only true when A and B are the same number, just as it was with subtraction. Both of those fractions would be 1. So we get 1 equals 1. And finally, I just want to touch on this topic of order of operations, which some people call BODMAS or BIDMAS. And that stands for brackets, powers, or indices if it's BIDMAS, which is squares and cubes, division, multiplication, addition and subtraction. And those are supposed to have the same priority, and those are supposed to have the same priority. So really what children need to know is that they have to evaluate the insides of brackets first. And you can teach them by just doing lots of exercises with brackets, both with numbers and with numbers for letters like these ones. And they'll get the hang of it. And they do also need to know that multiplication dominates the addition in a question like this. So 4 add 6 times 10, that's going to be 4 add 60, not 10 times 10. So there is a little bit of work to be done on order of operations. So if your children know they have to do brackets first, and they know to prioritise multiplication, division over addition and subtraction, they've got it. And again, that can be done with lots of practice. It's not particularly intuitive, so it needs to be practiced often. Your extension work for this topic? Well, there was loads of extension work in this column already. Plenty in there to really challenge children. And of course, you can set these up with a third column if you like. If you've got a whole class that's ready for a big challenge, I used to set my 11-year-olds SDPQ questions, and I would just give them 2 numbers. So at a simple level, those numbers might be 8 and 2. An SDPQ means sum, difference, product, quotient. That's the result of adding, the result of subtracting, the result of multiplying, and the result of dividing. And that's really nice vocabulary for whole classes of students to learn. SDPQ, sum, difference, product, quotient. And they're going to get a mark for each answer. So if we add these numbers, we get 10. There's a mark for 10. Every child should be able to get that. about if we find the difference, the result of subtracting? Well, one of the answers is 6, but what if we started at 2 and subtracted 8? You need your number line to hop back 8 spaces and discover that that's -6. We get 2 answers for subtraction because it's not commutative. Product, 8 2s or 2 8s, they're both 16. Multiplication is commutative. And quotient division, well, 8 divided by 2 is 4. What's 2 divided by 8? If you had 2 cakes and you divided them by 8 people, well, you can write your division as a fraction. It would be 2/8, which is 1/4. So your 6th answer, and there usually are 6 answers, is 1/4. And of course, those numbers don't have to be easy. Just as with the second column of this worksheet, you can give children questions they can't actually do. It's fine to do that here as well. It's fine to struggle. It's fine for you to struggle. You just say, oh, well, it's secondary school, so I haven't done it recently. I might need to look at that again. Pop into my Expert Primary Maths Teaching Facebook group, post a question overnight, come back to them tomorrow and you'll have a good answer and a good explanation. Don't be afraid to say that maths is hard. If you never find it hard as a teacher, how are your children going to feel comfortable in finding it hard? It's great if you can model for your children being stuck, not panicking, going away thinking about it and making a bit of progress over time. Then they'll learn to be comfortable when they're stuck too. So your takeaways from this video are that becoming familiar with algebraic notation takes lots of practice, but it's really easy to build in challenging extension activities, which will give all your children lots of time to consolidate being fluent with this and will also challenge them to review all their primary maths. We need to explore the commutativity of the 4 operations again using algebra, and we need to not panic too much about BODMAS, but we need to make sure children know to do brackets at first and then prioritise multiplication and division over addition and subtraction. And again, that requires practice. If you've any questions or comments about this video, please write them below. If you liked it and you'd like to find this channel again, please subscribe or give us a thumbs up. If you've any criticisms, they're hugely welcome too. Just put them in the comments. I love feedback. Critical feedback is very helpful, but sometimes people notice something and they just give a thumbs down, and that's not really very helpful because I've no idea what that means, and you just look at it going, oh, I wish they'd just told me what it was they'd like to be better. The next video will be all about missing number problems with algebra, which includes cases where there are 2 letters and you have to find possible results for those 2 letters. Hope you'll join me for that video soon. Bye for now.